Hi! In general, and especially now during these COVID-19 times, getting ourselves and our kids to exercise can be challenging. Many of us are stuck indoor, in front of the computers. Thus, the aim of this project I've started, with the help of Hashem, is to let us exercise in front of the computers with the help of the computers. In this first game, I'll demonstrate how to connect a stationary mini bike to computer using an Arduino-compatible microprocessor card and to modify the Unity Kart microgame tutorial to use the mini bike rotation speed as input. The hardware we'll be using consists of a mini bike, an Arduino-compatible microprocessor card, Arduino XIAO, a USB Type-C to Type-A cable, and some red and white wire. In addition to this, we need a soldering station and solder. I bought the mini bike at a local site, but similar mini bikes can also be found on Amazon or on AliExpress. The bike comes with a built-in speed, distance, and calorimeter that uses a magnetic reed switch. To connect the mini bike to computer, I used a Arduino XIAO microprocessor card. I chose it due to its small footprint and low price. Like with the bike, I bought mine at a local store. As mentioned before, the bike comes with a built-in speed distance calorimeter that uses a magnetic reed switch. The first thing in order to connect the bike to computer was to cut the wires between the speed meter card and the magnetic reed switch. After that, I reconnect the speed meter card with added wires to connect to I/O card. Positive wire was connected to input pin 1 and negative wire to GND pin of the Arduino. Finally, I put the speed meter back in place and secured the microprocessor card in place with some tape. I later noticed that the card kept getting loose and the wire got disconnected, having to solder it back, so I improved the security of the card with some hot glue. With that, we were finished with the hardware. Now let's move over to the software. The software used in this tutorial is Arduino IDE, Visual Studio, and Unity. All of them can be downloaded for free. The Visual Studio can be downloaded together with Unity through the Unity download. After installing the Arduino IDE, in order to program the Arduino, we need to set the board manager, additional board managers. So we go to Preferences, and in additional board manager URL, we need to add this URL. Then we go to Tools, Board, Seed CMD, and then we select the Arduino XIAO. Our program going to consist of an interrupt function that's going to take the pulse and we're going to write to a serial output. So we're going to define our input. We are using the internal pull-up resistor. And then we defined our interrupt. So whenever we have an input, we're going to call our interrupt function that we created. And we open and configure our serial port connection. In our loop function, we're going to send a heartbeat function that can be used to detect that we have a connection between the card and whatever program we do in Unity. In our interrupt function, we said that when we have an input pulse, we write a byte 1 to the serial port. We then verify our code, and after that we upload our program to our card, our processor card, and after that we open the serial monitor and we start paddling on our bike, and we see that we have, on every round we get an input. We get a byte 1 coming from the bike. We now move over to the Unity part of the project. In the Unity part we're going to use a built-in tutorial called Karting Microgame, which is available in the Learn tab in the Unity Hub. We're going to start a new microgame tutorial project. Out of the box we have here a pretty little kart game that can be played from keyboard. However, we want the speed or more precisely acceleration to be controlled from the bike pedaling rather than from the keyboard. To do this, we need to edit the ArcCard CS script. First thing we're going to do is we're going to add support for IO system, and we're going to add serial port. So we include system IO ports. After this, we're going to add a serial port object. Our COM port being COM4 and our baud rate being 9600 baud. Just as we defined when we did the programming of the Arduino Kart. In the awake method, which is run when the car is first initialized, we open our COM port, and we also set a COM port timeout. Now finally, we want to replace using the keyboard for acceleration to using our bike pedaling for acceleration. To do so, we find where is the keyboard input taken and used, and we find this in the fixed update method, which is run periodically. First of all, we reset the effect of the keyboard input by resetting the acceleration to 0. We then try to read the acceleration from the bike. So we read byte and we multiply it by 20. As we previously programmed our card to send byte 1 whenever there's an input for pedaling, if we get an input of 1, we set the acceleration to 20. And if we don't have an input of 1, the acceleration will be 0. So whenever we have a round, we'll push the car to accelerate. We also print the acceleration to the console. With that, we have actually finished our project, and we're ready to save and hit play. Before we do that, I want to give my thanks to Kenneth Anderson at Inscope Studio, who taught me how to set up Arduino and connect the serial output to Unity. In his YouTube video, you can see in the end of the video, there's a link to it. There's also another video, a similar bike game that I found, that I also start the link in the end of the game. And all of the code and a wiki can be found in the GitHub for the project. I also invite you to visit the webpage of Health Games and the blog that will give update of future progress of this project and other projects. Now let's go pedaling.